social construction of technology as a theory within the field of science and technology studies. Advocates of SCOT, that is, social constructivists, argue that technology does not determine human action, but that, rather, human action shapes technology. They also argue that the ways a technology is used cannot be understood without understanding how that technology is embedded in its social context. SCOT is a response to technological determinism and is sometimes known as technological constructivism. SCOT draws on work done in the constructivist school of the sociology of scientific knowledge, and its subtopics include actor-network theory and historical analysis of socio-technical systems, such as the work of historian Thomas P. Hughes. Its empirical methods are an adaptation of the empirical program of relativism, which outlines a method of analysis to demonstrate the ways in which scientific findings are socially constructed. Leading adherents of SCOT include DarwinPeacock and Trevor Pinch. SCOT holds that those who seek to understand the reasons for acceptance or rejection of a technology should look to the social world. It is not enough, according to SCOT, to explain a technology's success by saying that it is the best. Researchers must look at how the criteria of being the best is defined and what groups and stakeholders participate in defining it. In particular, they must ask who defines the technical criteria success is measured by, why technical criteria are defined this way, and who is included or excluded. Pinch and Peacock argue that technological determinism is a myth that results when one looks backwards and believes that the path taken to the present was the only possible path. SCOT is not only a theory, but also a methodology. It formalizes the steps and principles to follow when one wants to analyze the causes of technological failures or successes. Legacy of the strong program in the sociology of science. At the point of its conception, the SCOT approach was partly motivated by the ideas of the strong program in the sociology of science. In the seminal article, Pinch and Peacock refer to the principle of symmetry as the most influential tenet of the sociology of science, which should be applied in historical and sociological investigations of technology as well. It is strongly connected to Bloor's theory of social causation. Symmetry. The principle of symmetry holds that in explaining the origins of scientific beliefs, that is, assessing the success and failure of models, theories, or experiments, the historian sociologist should deploy the same kind of explanation in the cases of success as in cases of failure. When investigating beliefs, researchers should be impartial to the truth or falsehood of those beliefs, and the explanations should be unbiased. The strong program adopts a position of relativism and neutralism regarding the arguments that social actors put forward for the acceptance, rejection of any technology. All arguments are to be treated equally. The symmetry principle addresses the problem that the historian is tempted to explain the success of successful theories by referring to their objective truth, or inherent technical superiority, whereas he is more likely to put forward sociological explanations only in the case of failures. For example, having experienced the obvious success of the chain-driven bicycle for decades, it is tempting to attribute its success to its advanced technology, compared to the primitiveness of the penny farthing. But if we look closely and symmetrically at the history, we can see that at the beginning bicycles were valued according to quite different standards than nowadays. The early adopters valued the speed, the thrill, and the spectacularity of the penny farthing, in contrast to the security and stability of the chain-driven safety bicycle. Many other social factors have influenced and changed the relative valuations of bicycle models. A weak reading of the principle of symmetry points out that there often are many competing theories or technologies, which all have the potential to provide slightly different solutions to similar problems. In these cases, sociological technological factors tip the balance between them. That's why we should pay equal attention to them. A strong, social constructivist reading would add that even the emergence of the questions of problems to be solved are governed by social determinations, so the principle of symmetry is applicable even to the apparently purely technical issues. Core concepts. The following concepts and stages of SCOT are adapted from the empirical program of relativism. Interpretative flexibility. Interpretative flexibility means that each technological artifact has different meanings and interpretations for various groups. Baker and Pinch show that the air tire of the bicycle meant a more convenient mode of transportation for some people, whereas it meant technical nuisances, traction problems and ugly aesthetics to others. In racing, air tires lent to greater speed. These alternative interpretations generate different problems to be solved. How should aesthetics, convenience, and speed be prioritized? What is the best trade-off between traction and speed? Relevant social groups. The most basic relevant groups are the users and the producers of the technological artifact, but most often many subgroups can be delineated. Users with different socio-economic status, competing producers, etc. Sometimes there are relevant groups who are neither users nor producers of the technology, for example, journalists, politicians, and civil organizations. Trevor Pinch has argued that the salespeople of technology should also be included in the study of technology. The groups can be distinguished based on the shared or diverging interpretations of the technology in question. Design flexibility. Just as technologies have different meanings in different social groups, there are always multiple ways of constructing technologies. A design is only a single point in the large field of technical possibilities, reflecting the interpretations of certain relevant groups, problems and conflicts. The different interpretations often give rise to conflicts between criteria that are hard to resolve technologically, or conflicts between the relevant groups. Different groups in different societies construct different problems, leading to different designs. The first stage of the SCOT research methodology is to reconstruct the alternative interpretations of the technology, analyze the problems and conflicts these interpretations give rise to, and connect them to the design features of the technological artifact. The relations between groups, problems, and designs can be visualized in diagrams. Closure over time. As technologies are developed, the interpretative and design flexibility collapse through closure mechanisms. Two examples of closure mechanisms. Rhetorical closure. When social groups see the problem as being solved, the need for alternative designs diminishes. This is often the result of advertising. Redefinition of the problem. A design standing in the focus of conflicts can be stabilized by inventing a new problem, which is solved by this very design. The aesthetic and technical problems of the air tire diminished. As the technology advanced to the stage where air tire bikes started to win the bike races, tires were still considered cumbersome and ugly, but they provided a solution to the speed problem, and this overrode previous concerns. Closure is not permanent. New social groups may form and reintroduce interpretative flexibility, causing a new round of debate or conflict about the technology. The second stage of the SCOT methodology is to show how closure is achieved, relating the content of the technological artifact to the wider socio-political milieu. This is the third stage of the SCOT methodology, but the seminal article of Pinch and Baker does not proceed to this stage. Many other historians and sociologists of technology nevertheless do. For example, Paul N. Edwards shows in his book, The Closed World, Computers and the Politics of Discourse in Cold War America, the strong relations between the political discourse of the Cold War and the computer designs of this era. Criticism. In 1993, Langdon Winner published an influential critique of Scott entitled, Upon Opening the Black Box and Finding It Empty, Social Constructivism and the Philosophy of Technology. In it, he argues that social constructivism is an overly narrow research program. He identifies the following specific limitations in social constructivism. It explains how technologies arise but ignores the consequences of the technologies after the fact. This results in a sociology that says nothing about how such technologies matter in the broader context. It examines social groups and interests that contribute to the construction of technology, but ignores those who have no voice in the process, yet are affected by it. Likewise, when documenting technological contingencies and choices, it fails to account for those options that never made it to the table. According to Winner, this results in conservative and elitist sociology. It is superficial in that it focuses on how the immediate needs, interests, problems and solutions of chosen social groups influence technological choice, but disregards any possible deeper cultural, intellectual or economic origins of social choices concerning technology. It actively avoids taking any kind of moral stance or passing judgment on the relative merits of the alternative interpretations of a technology. This indifference makes it unhelpful in addressing important debates about the place of technology in human affairs. Other critics include Stuart Russell with his letter in the journal Social Studies of Science, titled The Social Construction of Artifacts, a response to Pinch and Biker.